we're going to explore a concept that's very important to stoichiometry called the limiting reactant. To introduce the limiting reactant, we're going to return to our example of the perfect breakfast. And a few videos ago, I outlined what I thought was my perfect breakfast. 1 cup of coffee, 2 eggs, 3 pieces of bacon, 2 pieces of toast, and this makes the perfect breakfast. Now, with any meal, not just breakfast, you are often only allowed to cook as much food as you have ingredients. And inevitably, you're going to run out of one ingredient faster than you run out of other ingredients. Or to put it another way, you will consume all of your supply of one of the ingredients before you consume the supply of the other ingredients. And this ingredient that you run out of first, this ingredient that is consumed completely through the process of cooking your meal, is what we refer to in chemistry as the limiting reactant. Now, it's also called the limiting reagent. Reactant and reagent can mean the same thing. So in this particular breakfast, we see here I wrote out a, if you will, a balanced breakfast equation. 1 coffee, 2 eggs, 3 bacon, 2 toast gives me 1 perfect breakfast. And we know that these numbers here can represent coefficients in a balanced chemical equation. And they tell us something about the ratio in which moles of the chemicals, chemically speaking, will react to give you however many moles of product. Well, in this case, these numbers are referring to the proportion of ingredients you need or food items you need to make the 1 perfect breakfast. So to illustrate the limiting reactant, we're going to use this breakfast analogy. And I've written out the amount of supplies that you might have in your fridge to make breakfast. And we're going to see how many perfect breakfasts we can make with these food items, this many food items. So let's say you want to make breakfast for some people. You have some friends over whenever the lockdown has ended, and you look through your pantry and your fridge and you count up all your items and you think to yourself, okay, this is probably how much I can make. So we see that you can have enough coffee to make 3 cups of coffee. You've got enough eggs to make 6 eggs. You've got, 6 pieces of bacon, and you've got 8 pieces of toast. So let's see how many perfect breakfasts you can make. Now we have to take these items and apply them into this equation here to make a perfect breakfast. So I'm going to outline all of my perfect breakfasts using a different color. So let's start off with 1. So my first friend will get a cup of coffee. They'll get 2 eggs. They'll get their 3 pieces of bacon. And they'll get their 2 slices of toast. And that all goes together to make 1 perfect breakfast. All right, so that's enough food to cook for 1 friend. Let's see if I have enough to cook for a second one. Well, I've got another cup of coffee. Got enough eggs for a second friend. I've got enough bacon for a second friend. And I've got enough toast for a second friend, which means I make another perfect breakfast. All right, let's see if we have enough to make some for a third friend. Well, I've got my 1 cup of coffee. I've got my 2 eggs. So far, so good. But I don't have any bacon. I do have lots of toast left over, but I don't have any bacon. So that means I can't actually make another perfect breakfast. So how many perfect breakfasts can I make? Well, if I add these two together, I can only really make 2 perfect breakfasts because I'm limited by the bacon. I don't have enough bacon to make any more perfect breakfasts. And as you can see, the bacon was consumed first. The bacon was completely consumed in making these perfect breakfasts. And the amount of perfect breakfasts that I can make is limited by how much bacon I had. The bacon was the ingredient that we ran out of first. So in this case, we would call, the analogy is still holding, we would refer to the bacon as the limiting reactant. The limiting reactant is the substance that you run out of first. It's consumed completely over the course of the reaction. Once the reaction is finished, you do not have any more limiting reactant left. So this is an important concept in stoichiometry, in chemistry. Your reaction can only proceed as long as you have enough of each ingredient, each reactant. And the limiting reactant is that reactant that is consumed first. Once it is consumed, the reaction stops. We can't go any further. Now, what happens to the others? Well, you'll notice that I've got some excess of other reactants. So let's say I've got 1 cup of coffee left over, I've got some 2 eggs left over, and I've got 4 pieces of toast. Let's just gather all these together. All these highlighted in green, the 1 coffee, the 2 eggs, and the 4 pieces of toast, these are all called excess reactants. They're in excess. I have sufficient amounts of them. I don't need to worry about how much I have. Once the reaction is complete, I will have an excess of these reactants. So in a chemical reaction, you're going to have at least 1 limiting reactant, and then you'll have your other reactants are usually going to be in excess. You'll have more of that. You'll have more than you need to run the reaction. The thing with an excess reactant is that after the reaction is complete, you will have some remaining. You will have some leftovers of the excess reactant. So there you go. There's the limiting reactant. It's consumed completely over the course of a reaction. And you have the excess reactant, which will remain in excess. You'll have leftovers of it after the reaction is complete. The other key point here is that the extent of your reaction, or the amount of product that you can expect out of a chemical reaction or out of, let's say, a cooking recipe, is determined by how much of the limiting reactant you have. Once the limiting reactant is completely consumed, your reaction stops. All right, so we're going to explore this concept a little bit more in a couple in videos to come. This is just a little analogy to show you why it makes sense, and hopefully you can kind of see why this makes sense. I encourage you to do some reading, into limiting reactants. It takes a little bit of getting used to. I find the difficult part in terms of stoichiometry and chemistry is just learning how to determine what reactant is the limiting reactant. And that's what we're going to do over the next couple of videos. But hopefully at least you understand the concept here of why we're looking at limiting reactants. All right, so that being said, I'm going to see you in the next video, Hopefully this helps.